underway. Welcome. Welcome. Okay. This is the motivation for the presentation today, is really looking at how we can automate deductive research using technology. And in this case, I'm going to talk about structural equation modelling and give you a little bit of information on that along the way. I'm not going to go into a lot of detail. When I originally did the SEM course, which was taught to me by a professor from UQ 20 years ago, it was a 2-week course. The likes of Lisa Bradley and those sorts of people were in the class. So books are about this thick. So I'm not going to go into a lot of detail, but if I don't go into enough detail, just yell out, ask questions. So here we go. All right, so basically deductive research is based on validated theory. So we're not talking about exploratory research. And later on you'll see why that's the case when we come to analysis. And I've just put a couple of examples there that I'll use later, all right? Most of these scales or questionnaire items, they come usually from the American Psychological Association. We also use them in field surveys. So when we run surveys in the field, so when people go out and reply to the Household Income Labour Dynamics Australia's annual survey by the Department of Housing and whatever, the federal government. In there's things like the SF36 health surveys and things. These are standard surveys that come from research institutions. And they're also used in laboratory experiments. So usually when we run a game experiment, run a trust game or something, at the end, while we're sorting out the money, we'll normally ask people a bunch of questions and maybe measure their trust or locus of control or something. What I'm particularly focusing on here is the costs, quality and response rates on surveys, which are always a big problem. And then the analysis costs. Those two things tend to take 80% of our time in research, when in fact we should be spending 80% of our time thinking about the research, not engaging in the mechanics. It's a bit like spending 80% of your time fixing the car engine and only 20% driving. It's kind of silly. We do it the wrong way around. Okay. So a paper which I'm going to use to compare and contrast costs. This coffee thing, basically, they're just telling us what we already know, cost supports in the collect data. And we get lack of responses, attrition bias, memory bias, and all sorts of horrible noise that gets generated through the methods we use. And we end up with dodgy research. So we want to optimize how we collect data, and it needs to be high quality. And then we want to reduce the cost of analysis. And of course, the cost of analysis also includes the cost of learning how to do this stuff. So just to give you an idea, in 2 weeks, I'm going to teach a course and just to get people started on the use of econometrics for 3 weeks. And I think I did from 100 to 600 level courses and 8 special courses here when I did my PhD here, just for me to come up to speed on how to do stuff. So it's a big investment, particularly by PhD candidates, I think. It's a massive investment. And we're constantly criticised for how we do it. Not my method. All right. So this is the statement of significance in it. This is in the Journal of Survey Statistics and Methodology. This is an Oxford journal, so it's a reasonably good journal. This study, basically, they go out and collect data using computer-aided telephone techniques. They then go back and they follow up on 3 occasions over 4 weeks with telephone interviews. And the whole idea is to try and improve the response rates and get the errors out of the collected data I think the whole process they went through in themselves induced bias. Right? Could you imagine calling up somebody and saying, "Excuse me, but I need you to review your question because it's too noisy"? That's basically what they would do. But we'll use it anyway because it's very recent, mate. So this is 2024. They finished the research at the end of last year. So this is what their study goal was. And I just talked about the method. They did it while they were collecting data on college graduates. The results depends on where you look in their paper, but basically they improved things by about 10%. This is what they expected. They only expected to reduce costs by between nothing and about 6.72%. And they expected to improve the quality by 1 to 2%. So these weren't massive goals they were trying to achieve. This is actually the table. I'm not going to take you through the detail. I just want to show you quick the numbers. So here we are. There was 8,000, sample of 8,000. Just pretty big. And they saved $22,000. This is the control group that was treated, and they sold less than 10%. Saved less than 10%. Right, so this is the salaries. Up here, saved 1,072, 1,260 and 84, right? So we're talking 1 or 2%. Right. Here we are, the salaries in the next stage, they saved $170. It come down here and play with the math, and they saved $1,380 and 78. And this is what their summary was. This is what's called gilding the lily. Yeah, I don't know where this one came from. Yeah. I'm not going to go through their method. All I'm going to do is I'm just going to show you how much trouble these guys did to address these things. This was a big effort, a really, really big effort. Right? There's some complex econometrics in there. Somebody spent a lot of time in Stata programming that up. How long would that take, Ben? A while, wouldn't it? Yeah, this one in particular is a horror, I think. That's a horror. Yeah. So I just want to do a quick compare and contrast here before I move into structural equation modelling and a proposition on how you can do this better. So basically, this was a National Institute of Health research project. I used ChatGPT to find out you get about $500,000 to $600,000 on average in there. Yeah. Divide that by 8,000 and you get about $107 per thing. Okay, that's pretty rough, isn't it? Then I used their figures. All right. So this is the treatment group. This is the control group. So that's really how much they saved. Okay. Now, what's amusing here is if we say that's about $70, right? University overheads are about 30%. So if you add 30% of that, you get the $107, which is about the same as that. So these numbers kind of pass the pub test. All right. How much would it cost if we use survey error? So I just want to share an experience with you. So I did a presentation, some of which I'm going to cover here, a while back, to Benno and a few of the others on a research proposition, which basically was to grab my masters and we were going to publish a paper and then use survey error to validate the APA scales. And Steve took my items, my questionnaires, took them one afternoon at 3 o'clock and came back to me the next morning and gave them to me in survey LM, right? And then I had a whole bunch. I had 500 different subjects. He grabbed all the information on the subjects and turned them into agents. He did that the following night. So assuming Steve is a Superman, which I think he is, and us normal folks will take at least 10 times longer, that's 20 days, yeah, that's 4 weeks, and at university rates is about $20,000 just to set it up. All right, these guys spent $500,000. Now, even if I'm out by 100% or 300%, we can see that there's a viable way of changing the way we do research. All right, so how do we do it? So this is just a thing that I think we need to discuss as a team, but this is a proposition. Basically, we do what Steve did. Right, so you punch your survey items, your survey LM. Now, what will happen is as we do that progressively, we're going to build up a library of these things. Yeah. Then you get your agent types, you know, all of the demographics on the sort of agents, and you build up a library of agents. Okay.
So in terms of the library of things, how would you structure it so that it's useful for future projects?
They're the 5 slides at the end I'm not going to cover because that's for confidential, I think, at this point. I will not cover that. But that's where we're heading, exactly where we're heading. The end goal is that an institution like BITA with this level of skills could free up potentially 80% of the time of researchers doing the hack work for data collection and analysis, freeing up researchers to have that time to think about their problems, to think about interpretation.
Yeah.
We don't spend enough time thinking on our research. We spend so much time as research slaves, basically. It's a lot better, at least we don't have to do the long arithmetic these days. The computers do that for us. All right, so we put the stuff in Survey LM, set her up, collect the data. Yeah. Now what we do is we then extract the data out of Survey LM, and then we can feed that into a tool like structural equation modelling where we can test the theory of interest. Yeah, and I'm going to give you an example in a minute. And then we can basically, initially we would do this just to validate the Survey LM system against the manual system. And then later on, we wouldn't have to validate. We'd have these validation papers, which we'd already produced, where somebody comes along and says, I want to do some work on trust, and say, okay, well, here's a manual paper, here's Survey LM. We've done a series of papers, or they're in the working paper series for BITA, and this will build confidence such that people will trust this process is as good as, if not better, than the expensive manual process, which we know is massively flawed. All right, so I'm just going to use an example of the thing I talked about before, where I looked at an experiment to test people's intention to trust, right? So if you wish, this is the theory that we would put in. This is just an example, right? So what happens when you have a trustor and a trustee is the trustor, the person who's going to extend trust sees risk, they assess that risk. They assess that risk according to this theory by looking at the ability, how well somebody, they want somebody to do something. Is this person competent? Let's say you want to go on an aircraft. You clearly want a good flight crew, right? Whether this person has high levels of integrity, if they're truthful, they're not going to corrupt you or something. And then the extent, benevolence, the extent to which the relationship benefits you. And you have a feedback mechanism where this works. And then initially, before you're even asked to engage in some sort of trusting decision, we have this underlying, what we call propensity to trust, which is kind of an innate thing and a function of how we were brought up, our culture and many other things. Okay, so that's what we're going to test. We're going to do that here by doing, these are the inputs to the trusting decision, and we're going to adjust the what we call the situational strength. So the scenario is a student has to do an assessment by the end of semester. They're currently not in a group. It's a group assignment. They're offered information on the ability, benevolence and integrity of that group. So in terms of ability, a high guy, these guys get 7s, these guys get 4s, something like that, right? That information is communicated via a vignette. What's nice is in Survey LM we can use vignettes to communicate to the agents what's going on. How well we can do that? Well, we're going to have to talk to Steve. So how well can we inform the agent is an important thing.
I think with the vignette, the good thing with Serverlab probably is they internalized the context quite well.
And that's what this is all about.
And that's the vignette issue that people criticize in terms of extendability.
Yeah.
So yeah.
One of the things I like about Survey LM, usually what happens, sociologists and psychologists do what they call a trial first. You trial all your instruments to see if you get what you want, you validate it and stuff. I'm not going to go through that. But for me, it took like 6 to 7 months to run the validation stuff. You've got to go and collect preliminary data, then you've got to correct the instruments, right? So you should perhaps iterate towards this through multiple processes, which is a bit of what Coffee and Co did with their surveys, right? They iterated. But the very fact iteration process corrupts the data. Yeah. And you never ever resolve it. With Survey LM, we could run one today, tweak it, and run another one tonight. In fact, we could set up a computer loop to run it 10,000 times, like a Monte Carlo simulation, right?
Well, I mean, you get also independency.
Yeah.
So all this kind of...
So I think it's going to remove a massive amount of costs on pre-tests. All right.
It also messes up, I mean, I think it's good. It's a good incentive story, because it also messes up all this econ experimentalists who emphasize, oh, you need to always pay people to incentivize, and that's the only incentive that you have to provide. Now we don't have to bother whatsoever. I mean,
well, there's a major conflict
because
between economics and the other scientific community of this.
Yeah.
Psychologists hate incentives, right? Because you corrupt. They know it corrupts the data.
It corrupts. Well, it can lack the selection effect, but also the good discussion is that psychologists say, well, people are motivated in different ways, not just monetary.
Correct.
But now we have this kind of tool that the context itself motivates people to behave as if they would be in this environment.
Survey LM, people don't have to pay the rent. It's the bottom line. All right. So basically, we put the instruments. These are the instruments I use. The intention to trust. This is the to find out about the intention to trust the individual in this situation. This is the propensity before they have to make a decision. So you measure their underlying level of trust. You expose them to the vignette. You do the intention to trust, and then you ask them in terms of how did you perceive the ability, benevolence, and integrity. So this is the feedback for each of the dimensions of the factors that load onto trust. Right. So the construct is trust. The factors are ability, benevolence, and integrity. This is the demographic information that was collected. Basically, this is the types for the agent. The types information. The typical thing: age, gender. Have you done surveys before? What's your job? In this case, we wanted to know what faculty they came on, whatever. You know. It'd be nice to have a standard set of agent criteria. Particularly if you're going to offer this as a service, then basically you might have to go as extensive as what the HILDA does with respect to personal information. But we've got lots of examples. We've got the HILDA in Australia, we've got the German socioeconomic panel, the British household panel, and of course if we collect data with Survey LM and we collect the data that was collected within those panels, in the case of the German one, we get 24 years of data we can validate it against.
Yeah.
in big populations of surveys of people who stay in over time.
I think you get a lot through the World Value Survey too. The question is, what additionally dimensions do you get through a panel data?
Yeah.
So how can you,
it's a time component.
So let's, for example, if you take, let's say, for example, you take the World Value Survey because it's so broad as a starting point, and then you build up. The question: what is the starting point? Is it building up because it's widely available, everyone can work with it, and then can you fine tune it? How do you fine tune the profiling based on different data sets?
Let me give you an example that I did just recently. So I did some surveys. I did some analysis on what happened in Victoria during COVID lockdowns to mental health. Now, what I used is information within the HILDA, which identified when those people, the date of the survey, before the lockdowns came in on the 15th of March. So I've used the time component of the panel, all right? Treated and untreated groups, right? Not locked down, answered the survey, am locked down, answered the survey. Using two-stage least squares, structural equation modelling techniques, I found that the mental health shock from lockdowns in Victoria were twice as big as what you would get if you had a major health scare, like you had to go in for an operation. So for economists or health economists, I think the time component is useful for policy testing. But what's nice is with survey you could do both, right? Because Steve tells me that you can inform an agent what happened previously or let them the memory component, right, is important, right? Because when somebody fills out that survey in the following year, they carry the history of having done that before and what's happened since.
Yeah, I think what I'm thinking about is like you need to start thinking about how do you create a human.
Yeah.
And what that means, and I think what the literature, social science literature is missing is that we only say, for example, for this question, it makes sense to use panel because policy, intervention, shocks, whatsoever. But we don't understand how does then that help us to better understand the human? Because in the end, you need to, when you construct a human, you want to get closer. If you know the profile, you need to then use this information and better see, okay, how does that feed into the human in the end? Or if you program one like like Minsky, and that's missing in social science. I don't know. You work more.
Well, in the econometrics literature, they've addressed it through method, right?
Yeah, but
you do macro or micro studies. If you do in a macro study, you'll do a difference in difference, right? But if you don't, if you have the micro data, you'll do a two-stage least squares because you can control the heterogeneity in the individual.
Yeah, but that's also a way of just getting rid of noise. But
that's all it is. Hopefully, Survey LM will reduce that.
But that still doesn't help us to fully say, okay, what do we need to get out of the panel data to create a better profile?
Yeah.
That's still not an answer.
And I think it's an important question. Imagine a situation where we have a virtual you for everyone, right? Where we could prototype. You could have a policy you wanted to test, and you test it against the virtual individual of every Australian. At the moment with government policies, we tend to use what we call a feed-forward method. For whatever reason, we make a decision, and then we do it, and then usually we make up excuses why it did or didn't work, right? Which is really a crazy way to apply resources, I think. It's certainly not how management does it in companies. Normally we would prototype. Try it in one division, see if it worked, and if it worked well, we'd roll it across the other divisions in the company. We wouldn't just roll it across the whole company. The risk is that we'll destroy the company, waste resources. Shareholders don't like that. I don't like that.
Person like Steve Jobs.
Yeah.
One should eat him money.
Yeah. We need to find one like that. Then we'll be fine.
So I like the way that Benno Torgler preempts my next slide, which is this is exactly what we were talking about, Benno. What do we need to have in here for our agent definitions in our data? Yeah. So this is just an example of the data that came out of the study I did. It's what we all see. It's cross-sectional. So basically, we're going to now step through this here. We've collected the data. We come down to this step here. We're going to move into here. All right. So what are we going to do with it? Now, the first thing we need to do before we're going to use structural equation modeling, and I'm going to use literal. And I realise not a lot of people do that. I mean, you'll see later on why I would use literal, because it could be automated. It's different from other SEM products, which are more click and driven by operators clicking boxes. M plus or something. Anybody use it here? M plus? All right. So what I'm going to do to start off is I'm going to confirm, do a thing called confirmatory factor analysis. And then as we go through this, I'll explain this in econometric terms for you. So if you wish, this is stage one in a two-stage list. And this is the structural model here. Okay. I'll show you how we do it. So this is the core literal model. So this is from Jorg's board, sure, I can't remember the second name. So it's a software package. So if you wish, you can look at, say, this bit here. Yeah. So what we're saying here is that these factors, in literal they call these endogenous factors, completely different definition. Economists concerned that the x's are correlated with the error term, right? And all this is saying is these are survey items. So this is intention to trust. Yeah. And if you wish an example, and it says, what is the extent to which intention to trust is explained by that survey item? That's all it's asking. And there's some stuff left over called an error term. So this is not all that different from what we usually see in a regression. Two-stage least squares regression. And as I move forward and show you some of the equations, you're going to say, I knew that already. And here we see we've got a couple of factors here, and we can see that we allow for intercorrelation. We can do that in our structural models called interactions. Multiply this by that. No. And on the other side here, so that's the Y model, if you wish, the output model. This is the inputs. So these Kasai's here are just ability, benevolence, integrity, if you wish. And once again, does ability get explained by these survey items? So these are the questionnaire items, or the items that Survey LM would respond to. And once again, we've got errors. Yeah, and once again, we can set up intercorrelations between those things. How this operates within the software is just through matrix arithmetic and a covariance matrix. So what we need is we just need Survey LM to kick out a covariance matrix. So how did I do it manually? I imported all the data into SPSS, scaled it, so we could automate that sort of thing in Survey LM, the software, and just output it as a .cov file in SPSS. And once I had that, I'll show you how I used it in this. It's a really simple, easy process that can be automated by a computer. You don't need to do it manually. So that's the underlying model. So they all have fancy names, and you can program them in different ways. I won't go through this, right? But what I will do is say that basically, if you take away the x's, what you've got at the core of this is a bunch of latent variables which load onto these outcome variables, and they have equations which are not dissimilar to what you normally use in econometrics. Now, this top one here says y11 is a function of this here. Y11 is a function of this here. Y11 is a function of this here, etc. So it's just solving a bunch of linear equations. Nothing unusual. So this is what you call, if you wish, the second stage in two-stage least squared structural equation. So these are just the simple equations. So this one here, see this one here? X2 is this. That's this equation right there. Now what's good about it is you don't need to program this. You don't need to sit down and write the code to do the interactions or any of that sort of stuff. The tool does it for you. So behind this is just a covariance matrix, which is used for matrix arithmetic as it calculates covariance and averages and everything. Right? Question. In a covariance matrix where this is A, and I haven't shown not A, what's the diagonal? What's the diagonal in the covariance matrix, guys? Of A, this, I haven't shown not A, but this is A and not A, and the diagonal is here. What is it? 1. What's the well? What I'm asking is what's the covariance of this with itself? It's not variance. Oh. All right. What's good about this is this thing kicks out stuff that we all use in our reports. So goodness of fit indexes, root mean error squares. So this is the iterator. Yeah. It does holistic tests, and I'll show you how that works at the moment by pumping out chi-squared, and you can use adjustments to the model and how chi-squared changed to optimize your theory. All right, so we can actually use this to work out what is the optimal intention to trust scale in a given situation. Because you're probably aware that, you know, I might trust Ben implicitly, right? The level of trust that I extend to Ben is certainly different to what I would extend to my bank. All right, I wouldn't trust Westpac as far as I can keep them. So context is really, really important, not just for trust, but in even things like locus of control and all sorts of stuff. It's very, very important. Well, so we can test this and do, these allow us to do very quick checks. Not only that, but we kick out the things that we expect anyway. We get the t values. We can standardize the model so we can see it in terms of standard deviations. And with these modification indexes, if we make a tweak to the model, we can automatically get feedback on whether or not it improved the model fit. Now, how it does that is literal. When you tell it what the structure of the theory looks like, you can see now why it's deductive. You have to start with the theory. You say, this is how theory works. It creates a covariance matrix of the perfect model. Then it grabs the covariance matrix of your collected data and it does a model fit comparison over the top of it. And it reports the differences between your data, your covariance matrix, and the perfect model data. The null hypothesis is that the covariance matrix are equivalent. Okay, that's the null hypothesis. All right, so let's consider this. So here's our standardized literal model. What we're going to do is we're going to do the Y model. We're going to initially do a confirmatory factor analysis on the intention of trust and survey items. These are the equations that explain that. You don't need to program these up, right? But this is what's behind it, just a series of linear equations that are solved using maximum likelihood, right? Which requires the covariance matrix. In this case here, you can see the items loading onto those explanatory variables, and this is the error terms.
So if you think about this, if you can automate it, you talk about how can we improve on the speaking to theory and searching for facts? Because that's what a survey lab can do. It can actually feed back into the theory and be even more dynamically. It reminds me a little bit, we can reduce this covariance stuff. CAPM, for example, this kind of challenge with covariance to explore diversity, and computational power was very limited, and therefore they had to try to find ways how to deal with this kind of. And covariance was a big problem for them because it requires so many calculations. What do we do? So, do you have any intuition how to feed back the empirics into the theory or test different theories?
All right. Yeah.
Yeah, because that's then what survey lab can bring once we automate it. We can be much more dynamic in this kind of.
Yeah. Okay, I'll run through an example now.
Yeah.
Because you can do that. Yeah, it's called model trimming. All right. So basically what's happened is the machine has created a covariance matrix of theory, and now we've created a covariance matrix of our data collection from SurveyLM. We're now going to run literal against the two covariance matrices. Say that are these compliant? So here's our questionnaire items. Yeah. Here's our intention to trust. Now we can do other things in here that economists never ever think of. Like everybody in psychology knows, if you ask a negative question, you get a different response than if you ask a positive question about the same thing. All right? So even in here, you can see that items 5 and 10 were reverse coded, and you put a factor in because they both carry the bias of the respondent with respect to the negative effect, the effect of a negative question on somebody. So you can do things with structural equation modeling that economists just don't think of. But the other thing you can do here, let me just take you quickly to the bottom here, and this will answer your question, Benno, is immediately you get feedback that we always look for when we run regressions. That is, what do the errors look like? How big is it, right? P-value type stuff. Here, you can see the p-value is quite large. That means, in this case here, that we do not reject the equivalence of the two models, the theoretical model and the collective model. So the data fits the theory here. We also get this wonderful thing called a chi-squared test. Now, if this didn't work, what we can do is we can rerun this analysis by selectively removing some of these items. Because depending on the context of where we are, for example, the items in Julian Rotter's propensity to trust scale, I think there are 20 items in there. And they ask questions as diverse as, do you trust strangers? Which is the question that economists always use. And they say that completely explains trust. It clearly doesn't, because Julian Rotter has included questions in there like, do you trust your teacher? Do you trust this? Right? So he's putting in contextual questions. Now what happens is, as you remove these, Benno, this chi-squared number will change. And if it changes by somewhere between 17 and 27, the model fit has improved. And you can automate that.
Okay, well, what we could do is we could actually, if that fitting not only through this kind of selector items, we can actually then automatically start collecting new data with new questions.
Correct. Or we can write a program where we have this great library of options, and we can do them in every possible combination, and automatically run the thing and use this chi-squared feedback to run optimization. Now, once we've run the optimization, and I'm going to show you later on the outputs, we can actually look in the covariance matrix and see which part of the matrix has the error, we can see the error in the data right there.
So now we need to find a way how to optimize.
We're going to have to write some code to do it.
Yeah. So
We're gonna have
because
to
it
write
needs
some
to
code.
it needs to be optimization through data that we have, but also through new data that we can collect.
Yeah.
Because we can run it automatically, you know, and then add additional variables, the context, feed them in. So we need to have.
Yeah. All right. I continue. So now what we do is we run what we call first order confirmatory factor analysis on each of the factors in ability, benevolence, and technique. It's the same process that we just went through before. We end up with a series of equations. We don't have to program this, it'll do it automatically. This is the output. You can see here, this is the one for ability. So basically all this says is, you said it the one before. That's exactly what we do here. We say it is ability, right? And then we say, does ability explain the questionnaire items? In fact, there are 5 items in that inventory. 2 of them were not applicable to this context, so I trimmed them out. And that's a normal process that you would use in structural equation modeling. Something that economists never do, right? They normally leave the stuff in.
Yeah, but trimming can be powerful, but it's not just trimming. Yeah.
The weakness I saw when I did this was to trim or not to trim.
Now we do.
It was a researcher decision. We can look at the math to optimize this automatically.
But we can also not just to trim or not to trim, but also to create or not to create.
Correct. And that is the weakness of of my study. The biggest limitation in this study was that, and when I was taught SEM initially, you know, the professor from UQ said the same. That this is you can destroy or improve your research with a researcher decision in this stuff. We need to be able to write some algorithms to solve that. You know. I'm sure we can do it mathematically. Because really what we've got is we've already got the covariance matrix so assuming the theory that is correct, we're going to make some deductions based on that, right? Then the weakness comes from, did we define the theory correctly? And particularly in psychology, there's a big inventory of research on things like trust. Right?
But you can also do, this would also mean, for example, we can do much faster robustness test and see if it doesn't work. We need to go back to the theory and revise the theory because we have done so much around the data that there may be something wrong with the theory.
Correct. Which is why one of the things I liked when I worked in the org psych area is the repeated studies, something that we don't do in economics. We don't get published if we don't.
We can do it once. The good thing we can do it just in one go, one paper.
Yeah. All right, I move on. So once again, you can see here that this fitted the data well. Yeah, this was good. Benevolence, the same. It fitted the data well. I did not reject. This one fitted well. Integrity fitted well. Looks like I've got a good model coming on here. You ready for this? Okay. So what we then do is we now bring these two together because we're going to worry about intercorrelations, right? Because what happens is if we're asking questions about trust, you have to answer the survey and they ask me this question and they ask the next question and you say, come on, that was just like the first question, right? That's correlation. So we just run it again, right? And this time I allow for intercorrelations, set these and check the model. And as you can see, what's happened? It rejected. Something wrong with the theory.
But the question is always again, when do you leave a theory? And you leave a theory if you have enough insights that something is wrong. So surveillance would allow us to do much more showing that something is wrong, that is credible enough to say, hey, there's really something wrong with the theory.
Yeah. Now I solved this in my thesis. I'm not going to show you how I did it, because that's a paper that Sophie and I collected. All right, but so what we've done is we've used the literal model, and we can use this to iterate towards what we call the path analysis. So this is the ultimate test of how stuff works. So this was, if you wish, this is the structural. So this is the first order equations here, and the structural equation of that block diagram that I put in the beginning. Yeah. And you can see that it rejected the data. Can anybody see where the problem is? Let me give you a hint. So if somebody was really highly skilled, would you trust them? Yes. Yeah? Positive. If somebody had high levels of integrity, would you trust them? Yes.
Don't trust the band.
If somebody's nice to you, do you not trust them? That's what this is saying. All right? There's a problem here.
Depends on the context.
Ah, thank you very much. That was the answer. That is the answer. The original study had an individual who hadn't joined the team. By the way, this scenario was the scenario that those students were going through. So this was first year statistics, and they had this person. The only difference was we had them imagine they hadn't joined a team rep, and they had to join it. So there was risk involved for them. If somebody comes up to you and say, you haven't joined a team, say, I'm your tutor, you haven't joined a team, and you've got to join these two guys. Yeah? So you think that's risky, right? You can test their ability, because I told them they get 7s, yeah? Their integrity, because Westerners tend to assume people have high integrity before we do something against them. That's our culture. But what about if I told you, they all always treat you right? Would you believe that? No, usually what happens is we test people out in the first dyadic experience with somebody, and if they treat us nice, then we do business with them again, or we engage with them again. Or if they treat us badly, we just get rid of them, right? We just go somewhere else. Context was exactly right. It was a one-shot game. Now, ideally, what we do in the lab is we'd run it like a behavioural game. We'd run 16 iterations of this, right? And see what changed over time.
Yeah.
Now, one of the things we can do with structural equation modelling is we can model this at time 1, 2, 3, 4. So we could see benevolence change as you had more engagement with people, and we could tweak whether they are nice or not nice to you. So we could do dynamic trust analysis here. I've never seen a paper do that.
I mean, it's really good that it depends is a really good heuristic to then go back and collect the data, extra data.
Yeah.
And the question is whether do we need in the theory generation also this kind of idea which factors are more it depends driven.
Yeah.
So that the theory itself needs to have this kind of ability to say where do we need to potentially collect more data than we have at the moment or less.
Yeah,
So that's an additional dimension in the structure equation modeling.
Yeah. Well, given your correct recognition that context was the problem, and given your desire to have more engagement in that context, yes, that's exactly what we have to do. How many personal experiences do we need to have to somebody in a particular context before we're willing to work with them permanently? And this strikes at the heart of what this was about, because the context was about somebody joining a team. And in business, no work gets done without teams. And when you introduce a new person into a teamwork environment, you've got a risk that that person will disrupt the team and destroy its productivity. So this is where types is important. Now, when we hire people into an organisation, HR departments go through a lot of trouble using psychometric scales in a kind of one-shot game to see if that person will fit our organisation. And then even though you fit perfectly, they put you on 6 months probation so they can get rid of you if you screw up, right? So this is a big issue for business.
So what you, okay, yeah, that's good. So you wanna, you apply this kind of setting in a team environment.
Well, this is what this is, it's a team environment.
And then you play Moneyball.
I play Moneyball by bumping people in and out and testing for the best fit. Now you can imagine, one of the things that I worked for a company called Hewlett Packard. So at HP, we had between me and the CEO, there were only 4 levels of government and 100,000, 4 levels of management and 100,000 people. So I used to manage very, very big multi-million-dollar projects. I had no employees, none at all. I was just responsible for the outcomes and the costs. So how do I get the people for my project? What I do is I have to go out and make selections. I need a software engineer, I need a hardware engineer, I need a project manager, I need a personal assistant, etc. Right? And that's how the real world works out there, right? You draw on the resources of your organisation to put together teams to meet the goals of your clients, such that you delight them. Right? That's quality. Quality is delighting people. You get more than what you expect. So this is what that was all about. All right, how did you do it? All right, so this is where I'm going to get, that 2-week course was about teaching you how to do this. Now, I haven't touched this for 19 years. No, sorry, 15 years. But I expect I can come back and I can do some of the stuff that you've asked me, Benno, in probably less than 15 minutes. Because this is just procedural, right? So up the top is just text. I've got 27 inputs, sample that, and it's telling me some information about the covariance matrix. These are the items in my Y model. These are the items in my X model. This is the covariance matrix that SurveyLM gave me. And then this is the number of equations. And then it's just saying, look, here we are. These are the matrices, right? So remember those equations, that one back before where I said psi 1 and then lambda 1 plus B1. That's this guy here, all right? And then you just tell it what the names of the things will be when it prints out the graphic. And then you just tell it how to run it. So you just edit this. So once you've got this as a text file, you can run it once, you come back and just edit it. If I want to get rid of benevolence, yeah, because it was crazy, I can run this model by just removing that and removing that line, or turn those items on. All right. So this is going to require initially people to do it, but we could also do this with AI. Right? We could detect that that was wrong, and we could set up a process where, on the probability that we don't get what we expect there, then remove that item. Right? So we could either do it procedurally with hard code, or we could do it with AI. And what I haven't got here is the results table, because I pulled the USB stick out. But let me come back to the results table last, because I want to just summarise on costs again. All right, and I was going to leave the cost discussions to the directors here, not public. All right. So I've had a look at the cost difference between what they did and what here, and I think it's probably not appropriate to go public with that. That's all right.
Yeah, that's fine.
So can I get my USB, put it back in, and we'll put up what you see.
She leaves in 2016 or 5. Because we done
I'm sorry.
where they
I was staring at her big like,
and then it comes.
On the side.
"You nasty."
Tony's having up.
Imagine, I think I can.
Just wondering how old they were
I'm 4 and
when you
5.
type up the code. 2006.
Was it the same?
5 years old.
That's basically.
They could be
It's a
Can you open this one for us, please? All right. Let's now just leave it as a text, and I'll scan down.
Yeah.
If you could just leave it as a text, just make it full screen, please, and so that people can see it. Because I just want to show you what we've got to work with. If we did this, I'll probably need the mouse to see it. All right. So this is the output file from Literal. So the stuff at the top, this is just the code that we ran, right? I'm going to mess up here, folks, because I'm a left-hander. So basically, we initially get information on correlations, right? Which is stuff we need initially. We then get parametric information, parameters of the ideal model. And then we get the beta coefficients and errors on every link in the model. So that's solving the equations. Yeah. We then start to get that information in covariance matrix terms. And then as we go down, we switch to the lambda and delta matrices, which are the error matrices. So we see the errors on each line in the structure. So you could actually look at this. I won't find it, but I can go in there and have a look in the matrix for benevolence, and I will find which item caused the problem. It was the covariance between this, and I'll see that the error was D than 0.05. And I can get that both in terms of the raw numbers or in terms of a standardized model. Now this gives us great power on making decisions on how to trim better, right? We can get inside the covariance matrix and see what's going on with the interactions between items. Of course, it doesn't solve the problem of should it be Likert scaled or should it be ladder scaled, but within the assumptions that we've made on the choice of scales and things. But of course, we could always, it's easy to change. You know, in the happiness area, one of the things that I don't much like is we use a 0 to 10 ladder scale. And I don't much like those. And the reason is that who knows whether a 4 to a 5 is the same as a 5 to a 6, so you get what we call a classic ordinal problem, right? But in a manual environment, that's almost impossible to test because it's so costly to rerun the survey with a different scale. But here we could do it. We could do it with survey LM pretty quickly. Yeah. All right. We get all those indexes. So all of this stuff is reported, right? So we can extract this information out and start making a decision about whether we trim using, say, the goodness of fit index, which is just a chi-square test of class, of the distribution of that stuff, right? You can see here our covariance matrices. We even get cute stuff. So this information would also be useful for extracting and putting in a report if you need to develop a report, either for a paper or if you've been doing this for a client, right? And you also get cute little things like, so here's the errors, right? So you all know that with respect to heteroscedasticity, it should be centered around 0 and symmetrical. And you can immediately see here that at least for this, you can see which item it was, but we don't have problems with standard errors on that. So you can check the errors. And it even knocks out Q plots for you to see how well it fits, the model fits the data. Yeah, it should be down here and it's a little bit up down here. Okay. So what you could do here is you could put the items to survey LM, put the agent information to survey LM, collect the data, create a covariance matrix, take that text file, feed it into Literal together with a covariance matrix using a batch file, which is what I just used, just the high performance computer center here at QUT to do it. It's HPC. Run Literal, call Literal, pass it the data, pass it if you wish to do file, run it, get this output, and then have some software on the back end to do the trimming thinking, which is the important part. Now, that whole process, so given that Steve took overnight to do the first 2 steps, and probably took overnight to do the 3rd step, and that we're mere humans that take 10 times longer, that's about 30 days of work, right? 5 weeks. $5,000 a week is $25,000, which is less than 5% of the cost of that project. Do you see the motivation? This is what could we do with $575,000. So that was at $595 was the average. We just spent $25,000 to collect the data, do the trimming, which they went through a horrible process to do that trimming. So it's less. So it's not a 10% saving as they said. Ours is the counterfactual. We get the potential of saving something between that and 90%. So imagine what we could do with $500,000 in grant that we didn't need to run analysis and data preparation. How much time we could have thinking about problems, how much extra time we could spend on writing the reports and the papers, which is the most important stuff, isn't it? Communicating the results. Most of us do work, shop the paper off the journal and don't do anything else. Nobody reads them. Whereas we need to market our work. The work we did on HRV, right, is important. Yeah.
So I mean, structure equation modeling is extremely powerful in a microeconomics context where you have a lot of contextual aspects that you can control relatively well. And you can do trimming or creating. Now, what about macro level? What about macro level? So if you go back to the 30s and 50s, where they started to create this big macro model, all this kind of, the early period of econometrics with Ragnar Frisch and Jan Tinberg and all these guys who, how useful is that in the context of quickly generating data, adjusting data.
I wouldn't
Maybe
use structural equation modelling for that, because structural equation modelling is founded on theory, it's deductive, and it's bounded, right? And a lot of that macro work is not, right? It's very data mining driven. I would, and this is a conversation I wanted to have with Steve, is if we had the covariance matrix, then, you know, we know what the equations are to do certain things, you know, for Cobb-Doppler's model or whatever we wanted to do, right? We would perhaps sometimes have to program up the regressions in software instead of using a tool like Literal. These guys are just saving us programming
Yeah.
the equations. That's all they do. That's all their model does, right? But it makes it really easy, right? I don't have to worry about that text file. I really don't have to worry about doing the coding for the reduced form or the structural form of the equations. You know, as you know, I do work in that space in education crime, working with regression discontinuity. It's a lot of work just to do one iteration of an OLS first stage in a reduced form to get some form of structural effect out, using, and that sort of research is data driven, a bit like macro.
Yeah, see, like it works at the meso level with the group stuff.
Yeah.
Being in and optimizing groups.
At the macro level, I think we're going to have to be programming some regressions.
Yeah, exactly.
We're going to have to.
Anyway.
We could do choice theory with this. We could do choice theory, but I don't think we can do. We can't solve the Kaplan problem.
Well, the campaign was just a trick to reduce computational power requirements.
Yeah, that's a really complex and
So the more interesting
unbounded model, right?
The more interesting instead of the one before that you use is how can you know, it's kind of you diversification leads to, you know, the possibility to perform better. And so that was I think that's a bigger insight for me. So Markowitz was more interesting to me than what came afterwards.
Yeah. Yeah. So that's it.
Very impressive.
So you shouldn't be scared about structural equation modeling. There's a module in Stata now. In Stata, literally, it's just a couple of commands. You just tell it what the x's are, what the endogenous and latent variables are, and just hit the button, and it'll knock out a lot of the stuff that comes out here. Not as much, but you get goodness of fit indexes and all that sort of stuff.
But, yeah.
Behind that in Stata is you need the Meta package on there, which is the matrix arithmetic add-on for Stata. I don't know, does the institute here have Meta? A Meta license? Does QUT have a Meta license for Stata? If not, you need it.
Bohm was emphasizing it should be. Bohm, when he was here,
Yeah, he's the perfect person to ask.
He emphasized that it's really important.
Because he's the guy who wrote the code that I use for my structural equation modeling in Stata. Yeah.
So what do you think that, again, I think structural equation modeling will become really for economists also much more interesting now that we have AI. So what do you think is the issues why economists don't work with that tool?
Can I be cynical?
You can be whatever.
So on the 6th of November, I've signed on for a online conference at the London School of Economics that's going to discuss the use of AI in economics.
Yeah.
Do you know what the theme of the conference is?
Oh, I think I remember you
How it's going to take our jobs.
Take our jobs, yeah.
So if you can imagine, a good analogy is these guys are all blacksmiths in 1898. And they're not talking about what we can do with these new things called motor cars. We're worried about how they're going to take away our ability to put little bits of metal on the bottom of horses' feet using nails. It's kind of weird, isn't it?
Yeah,
I don't think we're even there. I think there are groups, particularly in the US, that are already moving down this space better. But my experience going to the economic conferences in Europe and my experience with the behaviour of the Royal Economic Society is I think they see it as a threat.
yeah.
Instead of an opportunity, I think it's an opportunity.
I mean, I understand that it's applied economists. They are reactive. So I understand that they don't. Why they're focusing on this kind of job loss instead of understanding methodologically. But I was wondering about all these econometricians, good econometricians in economics.
Well,
Where are they in the thinking process?
Well, I had that same thought quite some time ago. So as you know, I teach econometric courses. And I looked at people like Kit Baum, who are the experts in that space, right? Who are the cutting edge on what's happening with econometrics and econometric methods. Him and Jeff Waldridge and Green and among others, right? And I see nobody who's come out with new methods using AI and offered them as either training courses or even if I look in Stata List and I have a look, I can't see anything in there on AI. Right? So I suppose if you're the Stata Corporation, you're worried that AI is going to kill your company. Because it could.
Yeah, I understand Waldridge that they're slow. They're focusing on textbooks and how a field can use those tools. So these are sometimes second movers because they just synthesize knowledge and then they put it in the textbook. I was wondering, for example, if people like, I don't know, Judea Pearl as an example, or this hardcore econometric guys, starting from history, Ragnar Frisch to now where you have less because they have become even more applied than the past.
Well, I think there's a massive opportunity out there to run courses to teach people how to do it. Right? Because I don't think that your bog standard econometrician has got a clue. They're still running Stata, they're still running difference in difference models, they're still running RDDs or two-stage least squares. They're still programming the code for Stata, or they're using some other software package. They're not there, Benno. You just got to have a look at it. Remember the stuff that Marcus used to do?
Yeah.
Right? He was way ahead of everybody else. They're still not caught up with Marcus, and Marcus has been gone nearly, 6 years?
I think based on what we discussed in the beginning, how can you bring structure into the usability of past experiments and insights? I think we can actually use StatDoc as a guiding principle. Yeah. That's what de facto Marcus generated. And StatDoc can become even more interesting once you have in your database 200, 300, 400 studies. Because then you also can play with the insights from the studies as well as with the content of the studies and the adjustments of the studies.
Do you guys know what StatDoc is?
So,
can you explain it, please, Benno?
Well, I think Marcus tried to increase transparency by building a platform where you can actually see what's going on in your analysis, and the entire process is recorded. So everything is in there and easy for you to follow. I mean,
it almost produces a research log for you.
It's a research
in detailed levels on what you did with your computer, how you move files around,
and you can adjust quickly. Very simple, in a simple way. So it's very user convenient. But I think what I what's now becoming really interesting is that now we can add the richness of this AI, richness of cerebral LM, richness of being able to do these large-scale studies, and then think about what happens if you combine those large-scale studies.
Almost like a study of studies technique.
Yeah, study, but then also instead of doing meta-analysis that relies fully on what already has been done, we can actually play around more dynamically.
We can simulate.
We can
run
simulate, like
simulations.
play around
Yeah.
with.
Yeah. And the saving on the data collection is going to give us the money to do this, right? So it means that when we make offers to ARC now, using this sort of thinking, we can have more deliverables than we ever had before. We're going to run 1,000 competing models across different strata of society. Right? We'll run it for the poor, the rich, the ultra rich.
Yeah.
We'll run it for males, for females. For people to identify this way or that way. In the past, we could never do that because we've never had the time or the money.
Non-linearity?
Yeah,
Non-linearity? Between non-linearity, like you mentioned, also the scales.
Shelley from
Issues.
TML wants to ask a question.
Other questions from online questions.
Shelley, did you want to ask your question?
Thanks so much, Jen. Can everybody hear me?
Yes.
Oh, great. Oh, thank you. I have just Shelley Franson here from Transport and Main Roads. I know there's a couple of us hiding in the audience from the Research and Insights team. So we run a lot of surveys, focus groups, interviews with a large customer contingent in our organisation. And thank you so much for this morning. It's been really interesting. I guess my question is around, we're working in a space right now where we're barely allowed to use, I guess, synthetic data to test our surveys and our research apparatus, let alone use it for our research on the ground. And our currency is really around public trust and customer engagement. And we also have a real responsibility to make sure that anything we do includes our marginalised communities, rural communities and vulnerable people, people with accessibility issues and things like that. So I just wonder what your views are on, I guess I'm assuming this is across government, how we can move forward in this space. We're in a space where we want to try new tech and we want to run new programs, but we really need to cross our T's, dot our I's in terms of ethics and privacy and all of those other things. So, and we all want to move forward in this space, but it's a really tricky space for us.
Thanks for the question. I think this is a really important question. It's one that Benno and I have discussed before, this notion of ethics, whether we got the right to do it. So the notion of ethics is if we went out and we collected data from somebody and we put questions in a survey, there's a potential that we could cause harm. And if we cause harm, it's unethical and therefore we can't do that research. So I suppose in the first question, in the first situation, we can't cause harm to an object agent in a computer. The risk we've got is that the way that we set up the agent didn't reflect the society or the minority or whatever it is that we want to run the test at. That is, does the agent truly represent our population? And I think that's something we need to think about, Benno. Right? You already talked about setting up a society. Yeah. So that's the first thing. There's another problem. And the other problem is this. Do I get the same response from an object agent that I get from a human? Yeah. And this is where those first couple of steps in that 8-step thing is that we need to revalidate all the important scales. So if you wish, if we went out there and we did a survey of all of the research that's been done in the last 10 years and we ranked the top most used APA or other instrument or tool and we progressively worked through that list and we revalidated them, then what we would have is we would have a level of trust in the AI type tool that it was going to behave like humans. At that point, given that we can't harm a computer agent, and given that the responses that we're getting from the process that we're using is similar to what we would get if we used humans anyway, then I would like to think that we would actually reduce the risk of harm to community. And the low cost of this would allow us to test it on more types in the community. Often these days we only do a gender-based thing. And when we do a gender-based things, we just do male-female, right? But we've got a researcher in this institute that tells me that there are more types than that, right? So I think it provides an opportunity. Having said that, I wonder what lawyers and ethics people would say about what I just said, because I'm not a lawyer. We're going to have to address this sooner or later.
Yeah.
People are already worried that we're going to be taken over by robots. It's not going to happen. But any change like this, and it is a paradigm shift, I think, in how we do research, isn't it?
Yeah, I think so too.
It's a paradigm shift. And it's going to be tough for government. Government is quite conservative. So the people who are going to have to take the risks to do this are going to have to be us in the research institutes initially, and provide the evidence to the wider community that we're not going to harm society when we do it. Yeah.
I think that the training center offers the possibility to closely interact, with
Well, I think we've got a responsibility to go to government and present this.
Well, and also interacting how this kind of new tool of thought and exploration can be used to the benefit of society.
Yeah. Well, how long did it take the Queensland courts to accept electronic evidence? I remember, I'm old enough to remember when the Queensland courts wouldn't accept things like emails and things as evidence. Today that's changed. It takes time. Institutions are slow to change. They need to build trust and make sure that it's ethical and in the benefit of society, which I think is what we all want to do anyway. Does that answer your question?
Yeah, thank you so much. That was really informative.
I think the main takeaway point is that I don't see a survey LM agent harming anybody. It's the human that uses the information afterwards that could perhaps not behave ethically.
Yeah.
Whereas at the moment, the manual data collection process has the potential to harm people. That's why they put us through so much rigor when we have to get ethics approval, when we're going to go out. Particularly, I work with children. Going out and asking children questions in schools is really sensitive. I have to have a blue card. Ethics want to authenticate the questionnaires. I normally have to test them. They want to see the results of the test. It's a very onerous process because the potential of harming the children it must be avoided.
Absolutely. And I think with us, I guess we're lucky in our engagement space is our customers want to be engaged and they expect to be when we co-design and things like that. So it's a different space. But yeah, all of these considerations are really important moving forward. Thank you.
Of course, we haven't discussed the fourth estate. Whatever would the media do with this? We have a problem now where they cherry pick results and stuff.
I think that the good advantage now is, like, compared to the traditional studies where you have a very simple environment that you explore, now you almost present a meta study in itself. So it's the idea of cherry picking this study compared to this study will become less of a problem because it's a large scale way of exploring contextual variation within one single study.
Correct. One of the problems I've had with meta studies, Ben, is what they do is they take the results from all of these different studies and they start doing things like they compare averages and standard deviations to come up with what you need to work out a Cohen's D, to work out how big N needs to be. When those moments that they're using, those statistics they're using have come from completely different populations. So they're not relevant. You can't look at the average for I had this problem with life satisfaction. You can't You can't look at the average happiness of a German and say that they're less happy than Australians because the German number is lower than the Australian number, right? But that's what meta studies do. But what we could do is create a society and we have a distribution, right? And then we could have a look within portions of that society, which is, I think, what you do at transport, right? You have to worry about if somebody's going to use the roads. You've got truck drivers to worry about, the car drivers, motorbike. You've got all sorts of different client types. And as you say, we could do it on one population and we could run multiple studies. Right?
But I think we have finally now a substantial amount of tools of thought and exploration that helps us now to get empirical evidence in understanding systems, which has been a huge issue over the last decades. Although we had some other interesting kind of theoretical concepts from the 50s. Think about the group formed by Talanfi and so forth. Now we actually have, so with this tool, a really possibility to push to the next level in terms of how to think about simulations, how to think about how contextual variations play a role, how uncertainty could play a role. So there's a lot of possibilities now to do systems, apply system thinking.
As an economist, what I think is great here is I could test policy against a society and get an idea of what's going to happen without doing what we do now, which is a feed-forward system where we make a massive investment in expectation that what we thought was going to happen did happen in the end. Right? We could run simulations, simulate society. What's crazy is, when you do a finance course, the first thing they teach you is that the past doesn't predict the future. Then we use the data from the past to predict the future. If the data from the past predicted the future, then we'd all be millionaires and we wouldn't be standing here. We'd be on the beach in Saint-Tropez.
It's the ultimate irony, isn't it?
It is. It's kind of crazy. Yeah. But don't you think it's constrained by our ability to be forward thinking, right? Because we it's like riding a bicycle looking backwards.
Yeah, but I think it's also it's thinking about simulations, like agent-based models, which are quite interesting ones because you can add a lot of heterogeneity. They are all rule-based.
As soon as you put a rule in, you break the rule.
So that means
rule.
they're very restricted in terms of the micro foundation once you set up the rules.
Yeah.
And they empirics or theory can guide the rule setting, but now we're actually creating empirical evidence.
Yeah.
So we're calibrating much better. At the same time that we run the simulations.
Yeah.
So we're doing both at the same time, which I think is really opening up the black box of this kind of how simulations work.
Yeah. Maybe that'll allow us to spend more time answering the question that I didn't answer before, from being how do we handle non-linear models, right? Which has always been a problem with us.
Yeah, exactly. Or scaling.
If you look at the context of life satisfaction, it goes like that on the lifetime, right? So what we do is we run a linear model across that U-shape, when in fact, there's no reason why we can't solve that graph, that U-shaped graph, by running an infinitesimal number of maximum likelihood adjustments across it. But that's hard to do, right? You've got to do a bit of programming to do it. But we know how to do it. It's just that we don't have the automation and tools to do it at the moment. Literally, I could use Little for that and write a complete code. If SurveyLN would give you the data. Just run a continuous maximum likelihood across the life course. It's a bit like, it's just time series, right? It's what people do when they're looking at the tick rates on the stock exchange. But unlike the stock exchange, we wouldn't have a starting point problem with happiness because we know that it starts a little bit before birth.
As soon as there are interactions, the non-linearity plays a big role.
Yeah.
And we have in social science, we have always relied on this kind of linearity a lot, just to make our lives simpler.
Yeah.
But now we can really explore this non-linearity and what does what does emerging properties actually mean? You know.
Yeah.
I mean, it's,
Yeah.
there are different ways of non-linearity. So I think that's very exciting. That's an exciting field for complexity science again.
Well, you know what we do in the life satisfaction literature? You know, when you've got this curve bit that goes up at the end as people come from the nadir of their well-being in mid-40s to being a happy guy like me, who's a lot older than that. We put an age square function in. What does age square look like? There you go. The question is, what does age square mean? It doesn't mean anything. It just means that it created a number which fitted the model. It was meaningless. We've got to go beyond that. We can't use mathematical tricks.
It's a limited
That's
shape.
a trick.
It's a limited shape.
That's a mathematical trick. All right. Your life never goes. Your age never goes exponential. Your age is linear. Right. The Earth goes around the sun at a predictable rate. That's a cheat. Clearly a cheat in that literature.
Yeah, I think it's interesting. I think we can also then go into, it's not just profiling, it's also like understanding people acting differently under different roles.
Yeah.
Like, you're acting differently here in the room, because, now in your work environment at home, you do differently. So there's a lot of heterogeneity based on you playing a different role within society in that sense.
Yeah.
And we have no clue empirically what that means exactly.
Well, we're doing things like we did in that paper, where we try and use primary source data, physiological data in some cases, to try and find out whether people have a well-being problem, right?
Exactly.
But ethics is not going to allow us to put a USB-C port in the back of everybody's head so that we can download their data. Think of the problems they give us now when we want to put a heart rate monitor on somebody, right? That's intervention. That's intrusive. And that brings up ethical problems, whereas SurveyLM may provide us with the opportunity so that we're not intrusive and we won't cause harm.
It would be interesting to look at like autobiography, because ideally we would want just like the whole life history of a person and put that in.
Yeah.
That's what.
Yeah.
Obviously they're biased, but that would.
Yeah.
And also there's selection bias to understand people, right?
You start to sound like the Matrix.
Yeah, exactly. Autobiographies and then much more what if, so more counterfactuals.
Yeah. Which we don't do much with these days because it's so hard and takes so much time. Are there any more questions, Jan?
No, any more questions online?
So, yeah, thanks Tony, super inspiring.
I think it's the future, guys,
super helpful.
for researchers. I think it's the future for government policy. This is where we're going to go in the future. We're going to simulate this stuff. We're not going to call. We get this notion in economics of being Pareto efficient, where nobody is harmed as a result of a policy change. Everybody benefits, and we know at the moment that our policies are not Pareto efficient. We can test the Pareto efficiency here using simulations and maybe get closer to the truth of what will work. And maybe along the way be more efficient in how we use our resources.
I think the good thing, some people have criticized Pareto efficiency, even Pareto, that there's more than just one Pareto efficiency. So we can start understanding different kind of levels and then find a societal agreement. This is reflects more the value system of, but
Well, Pareto efficiency is a very macro concept, isn't it? Whose
Yeah, but it becomes a
efficiency?
problem. But if it becomes a problem again if there are more than one
Whose
equilibrium.
utility?
And then you have these value systems, and then power plays a role. Who defines what to choose from? So I mean, this is very interesting.
Thanks, folks. If you got any ideas, please come and see me. Thanks, Dave.
Well done.